Hey guys, thanks for the message. Just doing a quick video here to talk about the structural elements that can be used to contribute towards additional strength, which I'm hopeful and suspect will reduce the need for such big columns. The big columns at 100 kilos per linear meter are wildly expensive, so we need to thin them down if we can and still retain the same level of safety. So talking through the structure here, the base containers here, North Tower, Northwest, this one here, the cafe, is being retained as a standard container without any modifications that fits the ISO specifications. The one next to it, we're calling that the staircase container, or the northeast ground floor container. We're opening up the end of the container here to be a staircase, but we're framing that up with 120mm by 120mm box section with a 6mm wall. So it's very strong. Is it as strong as corrugation? I don't know. The other end of this container around the back here, it has got doors on it which are closed, therefore it's the same strength. There's no other openings in this container except for that one opening. Okay, first floor, northwest, this one here, this is an office one. We've got two very big openings. One big opening there, one big opening there, another window there, and the northwest container has a window there, and another window on the opposite side. So that's significantly modified, but I'll get through some diagonal bracing elements in a second. Top floor here, northwest, the sauna container has a window opening, another window opening, another window opening. These are framed up with a very, very large box section, 120 by 120 on a 6mm wall. I suspect that wall is actually a lot stronger than what it was before we cut the holes in it because of the size of the framing. This one here, this is the northeast second floor shower block that has one window in the end here, which is again framed up with a large box section, in that case an 80 by 40mm, just where the window is. Okay, down here, these containers are unmodified except for a 1.2 meter by 300mm hole in the roof of each one, which is framed up with an 80mm by 40mm box section. First floor, this container here, which is the southwest first floor, that's going to have a series of windows down the length, probably 4 windows, details TBC. I've got to decide which windows to use. The back wall will be fully preserved. This will be where the doors are, which will open and close, so the strength will remain the same. The first floor southwest, this one here, will have the opening at this end using the doors, and the wall that connects this one with the other one will be wholly removed except for a column. Oh, and by the way, that applies to this container as well. Top floor here, these two containers, there's an aperture between the two containers which will be cut out in the middle wall and then reframed with box section. So various modifications. I can give the exact specifications and details if required, but I can't do it today because I'm not on site. I want to go and actually measure it in person rather than work off theoretical CAD. I'd like to give you the exact dimensions. Now, the bit that matters to you guys is what we can do in terms of modifications, in terms of diagonal ties. There's a lot of opportunities here. Let's rattle through them. So this wall here, I'm happy to do a diagonal tie from here to here and from here to here. On the top floor, I'm happy to diagonal tie from here to here and from here to here. If you prefer, we could go from here all the way down to there, or from here all the way down to there. On this wall here, I can do diagonal ties from there to there and from there to there. On the top here, for aesthetic reasons, I can't be doing diagonal ties because it just ruins the views. Over here, we can do diagonal ties across there and across there. We can do the same thing from there to there and from there to there. We can also go from there to there and from there to there. Same on the top floor, from that corner to that corner, from that corner to that corner. Now, the bit that I think matters the most, and which I don't believe you've factored in at this stage, is connecting the containers with the sway frame. Because at the moment, I believe you're treating the sway frame as an independent structure that's just holding some load of containers. We can weld every single one of these corner posts to the RSJs to which they're adjacent. We can also very easily, let's just zoom in here for a second. We can also very easily add some steel from the corner casting across to the column to weld there. We could also do it in the middle. That would be very simple, just a big piece of box section, or even flat plate if you prefer. We could do the same thing there. So we could therefore resist a lot of the racking force across the whole structure by transferring that load into the containers, which obviously have a less than ideal resistance because there are holes in the container, but they're reduced. So to summarize, the options are just simply welding the corner castings into the lateral beams going across the sway frame. Additionally, we could put a piece of steel midway up the container column to join to the long column. It's also worth noting our construction methodology in this is we will actually be building the containers, dropping the steel on, containers, dropping the steel on, container, dropping the steel on, and at the very end is when we will then go and add the column at the end of that process. So that being the case, the load of each element is bearing down on the one beneath it, and the columns will be put on at the very end once it's all in position. Because of that, it makes it very, very easy to weld the parts to each other because they're already touching. There won't be any gap between that corner casting and the steel above. They'll be touching anyway, so putting a load-bearing weld on there is not a problem at all. Other opportunities is we can very easily do a diagonal tie across the back here, from here to there and from there to there. We can also do, in this middle section here, where these two columns are at ground level, we can tie diagonally from there to there and from there to there. The reason is one side of this is bin storage, the other side is cycle storage, so having an obstruction there is really, really not a problem. I think that's most of it. Oh yeah, ties at the back here as well because there's no windows. Basically every single floor here, 1, 2, 3, we can do diagonal ties at the back, not a problem at all. Let me know your thoughts. I'm hopeful that's going to make a significant difference to the size required for the columns, because then we're going to tie the whole thing together and make it one big rigid structure. Oh, one other thing, these columns here, with the ties that can go at ground level and utilising the strength of these containers, I'm hoping these will be a lot thinner. I would like them to be 120 by 120 box section with 6mm wool, for the simple reason that I've got loads of it. So let me know if that's possible. I'm keen to hear your thoughts, or if any of this isn't clear at all, let me know. I'm really happy to do a set of elevation drawings and mark it up with what I'm thinking here, but because I'm in Ecuador right now and don't have a mouse with me, I thought this video might be easier. Let me know your thoughts, guys, and I'll see you soon.